We're going to be identifying and graphing sequences in this lesson. A go-kart racing track charges $5 for a go-kart license and $2 for each lap. If you list the charges for 1 lap, 2 laps, 3 laps, and so on in order, the list forms a sequence of numbers. So I'm going to demonstrate this visually using a table of values. So I have my laps, and I've got the dollars that it costs. So 1 lap, 2 laps, 3 laps, and so on. 1 lap is going to cost $5 plus $2 for the lap, so that would be $7. If I go 2 laps, I'm going to have to pay $5 plus $2 for 2 laps, so $2 times 2 is 4. So 5 plus 4 is 9. If I go 3 laps, I'm going to have to pay $2 for each lap, which is $6, plus the $5, which is $11. So I'm going to say that this right here, if I list the charges, so the charges from 1 lap, 2 laps, 3 laps, and so on would be $7, $9, $11, and so on. This is called a sequence. There's a pattern, and it's a cool one, and it's a sequence. A sequence is a list of numbers. Make that a little bit, there we go. A sequence is a list of numbers in a specific order. There's some kind of pattern to get from one number to the next. And you can see here, our pattern here is by adding 2. So the next number would be 13, and then 15, and then 17, and so on. An element is each term in the sequence. We call the first term the position number 1. The second term is position number 2. The third term is position number 3, and so on and so forth. Let's look at a table of values that shows the position numbers. So our position numbers are the first number, the second number, the third number. What would follow the third number? The fourth number. Then we have the fifth number, and then what would follow the fifth number? The sixth number. And our terms in this sequence would be 7, 9, 11, 13, 15, 17. Our domain is the position number, and our term of the sequence, f of n, is our range. Now some of you are saying, oh, I think I know, I think I get this. F of n equals, well, we're going to be adding 2. What are we going to add 2 to? Well, we're going to add 2 to 7. However, when I put a 1 in, I need to get a 7 out. So I want f of 1 to equal 7. So when I put a 1 in, I need to get a 7 out. So I would have, I don't think I put plus 2. We're going to be multiplying by 2. So 2n, and we want a 7 out on the very first one. So 2 times 1 is 2, plus 5 is going to give me that 7. So this is a little preview of where we're going. Right now, all you need to focus on is our sequence. I'm going to highlight it. Our sequence, 7, 9, 11, that's your f of n. That's your f of n, and it's the range. You can use the term and the position number of a sequence to write a function. Using function notation, f of 2 equals 9 indicates that the second term is 9. Use the table to complete the following statements. Well, the first term was 7. So f of 1 equals 7. The third term, let me write the terms again for you. 7, 9, 11, 13, 15, 17, and so on. The third term is 11. The sixth term, 1, 2, 3, 4, 5, 6, was 17. F of what is 13? Which term is that? Which term is 13? The fourth term is 13. And which term is 15? The fifth term is 15. The domain, I'm going to highlight this, the domain of f of n are the inputs. It's the number of terms. Or it's not the number of terms, it's the number term. So it's the term or position number. So the domain in this case is 1, 2, 3, 4, and I think it went on and on and on. So we put dot, 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 and that says just continue the pattern. Your domain is your position number, and the range of f of n, when I put the first position into my function, I get the first number in my sequence, which is 7. When I put 2 in, I get 9, and then 11, and then 13, and so on, and so on, and so on. And this is your sequence value. So it's your sequence value, your term value of the sequence. I like that better. Your term value of the sequence. It's actually pretty good. Term value of the sequence. And the explicit rule for this is f of n equals, we went up by 2's, so that means we're going to take 2 times our position number, and then we're going to add 5. The reason why we added 5 was so that f of 1 could equal 7. So the difference in going from one term to the next was 2. That's where this 2 comes from. And then we used 5 to satisfy f of 1 equals 7. This is called the explicit rule. Now, not all explicit rules are linear. You know what I'm talking about when I say linear, because you worked with linear functions before. So we've got this right here, n squared plus 2, and we've got 3n squared plus 1. In the next lesson, we're going to talk more about linear, but right now we're going to kind of explore some different types of sequences. For instance, this one, f of n equals n squared plus 2. So if I want the first term, I'm going to put a 1 in, I'm going to calculate it, and the first term is 3. When I put a 2 in to find the next term, I calculate 2 squared plus 2, and I get a 6. When I want to find the third term, I put a 3 in for n, and I get 11. And when I want to find the fourth term, I put a 4 in, and I get 18. So the first 4 terms in the sequence are 3, 6, 11, and 18. Let's try this next one. The first term, we put a 1 in. 1 squared is 1, times 3 is 3, plus 1 is 4. Put a 2 in. 2 squared is 4, times 3 is 12, plus 1 is 13. Put a 3 in. 3 squared is 9, 9 times 3 is 27, plus 1 is 28. Put a 4 in. 4 squared is 16, 16 times 3 is 48, plus 1 is 49. So our terms are for 13, 28, and 49. You go ahead and try, and I will show you the answer. Using the explicit rule, f of n equals n squared minus 5, we are able to find the first 4 terms, and I got -4, -1, 4, and 11. Number 7 says, find the 15th term. Well, when we have the explicit rule, we don't need to find the first 15 terms. We can go straight to the 15th term by just putting a 15 in. And when we do that, I got the 15th term would be 57. Now, recursive rule, I'm going to have to move some of this stuff. Let me move my 57 over here. Now, the recursive rule is a little different than the explicit rule. The explicit rule allows us to find any term value. The recursive rule defines the sequence in terms of the previous term, defines the sequence for the nth term in terms of the n minus 1th position. So the term before it. Here's an example. Write the first 4 terms of the sequence defined by the recursive rule. F of 1 equals 2. F of n equals f of n minus 1 plus 3. This is important. This is not, this right here means the term before f of n. Okay, f of 1 equals 2, f of n equals f of n minus 1 plus 3 for each whole number n greater than 1. So we know that the first term in our sequence is 2. What's the second term? Well, if I put a 2 in, f of 2 is equal to f of 1 plus 3. Okay, how did I get f of 1? Well, look, f of 2 is equal to f of 2 minus 1. I just didn't put the 2 in there because I know that f of n minus 1 is the term before. So if I'm looking for the second term, I'm going to have to find out what the first term was plus 3. Well, that first term is 2. F of 1 is 2. 2 plus 3 is 5. Now when I want to find the third term, I have to find the second term value and then add 3. Well, what's the second term value? Well, the second term value is right here. It's a 5. So I put a 5 in, and 5 plus 3 is 8. That's our third term. Now I want the fourth term. f of 4 is equal to f of 3 plus 3. So you keep going to the term before and then adding 3. Well, that fourth term is the third term, 8 plus 3. 8 plus 3 is 11. So there's our 4 terms of the sequence defined by the recursive rule. 2, 5, 8, and 11. 2, 5, 8, and 11. And you can see here, this means add 3 to the term before. Add 3 to the term before. Add 3 to the term before. So you keep adding 3 to get to the next value in the term. Okay, let's try that one again. F of 1 equals 4. So we know the first term is 4. What's the second term? Well, f of 1 equals 4. F of 2 is equal to the term before plus 5. So that would be f of 1 plus 5. Well, f of 1 is 4, and 4 plus 5 is 9. The third term, f of 3, is equal to the term before, which is f of 2, plus 5. F of 2 is 9. 9 plus 5 is 14. This is f of 1. This is f of 2. This is f of 3. What's the fourth term? F of 4 is equal to the term before, which is f of 3, plus 5. F of 3 is 14. 14 plus 5 is 19. So we have 4, 9, 14, and 19. Your turn. You get to write the first 5 terms in the sequence. Press pause, and when you're ready to come back and reveal the answers, press play. Okay, we're ready for the big reveal. The big reveal. I got 35, 33, 31, 29, and 27. And for number 11, 45, 41, 37, 33, and 29. Got one more problem for us. We want to construct and graph the sequence described. A movie rental club charges $20 per month plus a $5 membership fee. Use the explicit rule f of n equals 20n plus 5. So, in order to have the actual rental club, you have to be a member for at least 1 month, right? If you're a member for 0 months, then you're not really a member. So 0 is not part of the sequence. Our first term starts with the first month. Our second term is going to start with the second month. Then our third term will be the third month. So the first month, f of 1 is equal to 20 times 1 plus 5. So that's 25. Put a 1 in and we get a 25 out. We put a 2 in. F of 2 for the second month would be 20 times 2 plus 5. That's 45. The third month, f of 3 equals 20 times 3 plus 5. So that's 65. The fourth month would be 85. And the fifth month would be 105. And the sixth month would be 125. And so on and so forth. Can I connect the dots? I cannot connect the dots because this right here is discrete. Discrete. Once you go to the next month, you're charged a full $20 for the month.